Up to this point, all of our queries have gotten their information directly from data in a table. Like this query, for example, is pulling the employee ID, the first name, and the last name fields directly from the table and showing it to you in your result set as information. What about derived or expression fields? For example, if I were to put a comma and then say first name plus last name and call that full name, we get first name plus last name. Now it runs together a little bit ugly because I didn't put a space in there. So let me add a space before adding the last name. Rerun the query. There is no field in the employee table called full name. It is taking data, concatenating it in what's known as an expression field. Now putting the quotes around the expression field name is optional and actually not more commonly used. Let's take a numeric version of an expression field. Let's start off with just selecting the product name and the retail price. Now let's say right now that the exchange rate between the US dollar and the Canadian dollar is 1.1. So let's make a calculation. Retail price times 1.1. And let's run it. So if the cost is $61.48 US, it would be $67.63 Canadian. It doesn't seem to have a field name, so let's go ahead and alias this as CND $. Now we can see that that's the Canadian price. Before we change the scaling of our decimals, let's see how SQL Server views decimals. Both of these decimals would take up the same amount of memory in SQL Server. Why? What do they have in common? Well, both of these decimals are exactly 5 digits long. Now, they're not the same 5 digits. One is 5 digits with 1 decimal point. The other is 5 digits with 4 decimal points. The first one would be referred to as a decimal 5-1. The second one would be referred to as a decimal 5-4. How about another example? We could have more or fewer digits both before and after the decimal point. Here are some examples. The first one is a decimal 2-1. 2 total digits, 1 after the decimal point. 14.5 is a decimal 3-1. 14.45 is a decimal 4-2. 985.1 is a decimal 4-1. And 9982.16 is a decimal 6-2. 6 total digits, 2 of them after the decimal point. One thing to keep in mind about a decimal 6-2 is it could be a 0, or it could go up to 4 digits before the decimal point and 2 digits after. The decimal specification shows how large the number can go. Well, this expression field where we multiplied a decimal by another decimal seemed to have given us too many significant figures, because do we really want our calculation to come out to the hundredth of a Canadian penny or even more? Well, what we can do is we can have some control over that by doing what's known as a cast. So we'll cast this entire operation as a decimal and run it. Now notice the decimal defaults to having no decimal places. We want to set a precision and scale. For example, if I thought the price was going to go up to $999.99, I need to hold 5 digits. 2 of those digits after the decimal. This would be a precision of 5,2. Well, I have several products in the thousands, so I want to cast this decimal as a 6,2 and run it. And now we see our results just down to the penny. Let's examine this against a single result. If you take the number 3.85 and round it to 2 decimal places, you get 3.85. What if you round it to 1 decimal point? You get 3.90. Let's take a look. Type select 3.85 and you get 3.85. Okay, let's change this to select round to 2 decimal points. That is also 3.85. What if we go round to 1 decimal point? It's 3.90. what if we go round all the way up? It's 4.00. If we're to take these exact same functions and look at them with a 4, let's check our results. Select 4 produces a 4. 4 rounded 2 produces a 4. 4 rounded 1 produces a 4. 4 rounded 0 produces a 4. So the underlying data dictates the number of significant figures of how far the rounding can go. Let's repeat the cast function we saw from the last lab, but let's keep it in US dollars. Let's say cast retail price as decimal 6,2 as price. And what we've done here is we've effectively said we only want 2 decimal points. The original data went to the 1/10 of a penny, which is not necessary for our business. This 483 rounded down to 48. This 669 rounded up to 67. Now, if you just want to round, there's another function that you can use. Round retail price, comma 2 as round to price. And we can see we've gone out 2 decimal points, and it did effectively the same thing as the cast. Round retail price 1 as round 1 price. And notice $61.50, $110.70, $184.40, so it rounds to the dime. Now what happens if I go round retail price, comma 0 as round 0 price and run it? Notice we get $61, $111, $184. It rounded the decimals while leaving the significant figures in place. Okay, let's combine a few strategies here. Let's select the first name, last name, and hire date from the employee table. Now, what we're interested in viewing is all the employees who started with us after January 1st, 2000. So let's say where, hire date, there. We have 8 employees who were hired on or after January 1st, 2000. Now, what we want instead of first name and last name is the first name, last name concatenation with a space in the middle. We learned this in the first part of the lesson. And run it. Great. We have our first field which has first and last name, and then our hire date field. Now, our first and last name has no field header, which is probably not a good idea, especially if there's calling code expecting that to have a header. So let's alias this as full name. And then we see our result set. Now, these are all the people hired after the year 2000, but let's see them in order by the full name. We can obviously order them by last name, and we see Adams first, Bender Brown, but can we sort them by the expression field? Well, let's try it. Here's the same query, with the only difference is the order by is on the expression field. Let's run this. Looks like we can, and it's sorted by full name. We're going to use a convert function. Type convert. We're going to type n var char for Unicode variable length characters, hire date, and we're going to use style 101 and run it. And style 101 does month, day, year. Well, what does style 102 do? Oh, that goes year, month, day. Let's keep it as style 101 and alias this as hire date, and there we go. Now, the original data of the hire date was a date time field with numbers underneath it. Now we've converted it into a character date. The original name was hire date. The new name is hire date. If I order by hire date and execute, it should give me the first hired person. Now, is the year 2000 David Long the first person hired? I can see that in 1995 Barbara was hired 5 years before him. The reason is we converted this from a date field into a character date field, and in characters, 1 come before 2's, which come before 3's, and so forth. So we have an odd character sort, and we have a name conflict. Hire date refers to this field, which is the same name as this field, which is now not visible to us. It probably would have been a good idea to have given this alias a different name, like hired date or employment date. Run it, and now we are sorting by the original data, which shows the first date first. What if we had to use this name? What if calling code was depending on this? What's another way to solve this problem? We want it to be aliased as hire date. We want it to appear in this friendly format, but we want the sort to go against the actual field of the table. What's the name of the table? Employee dot hire date. So if you have a name conflict, you can fix the name conflict by referring to the 2-part name of the field, and you get your sort order with the friendly look and layout from your convert function. Time for Lab 3.2, Skill Check 1. Using what you've learned, make another field to express the price in Canadian currency called CDN $sign that is 1.1 times the stated retail price in JProCo's current products table. Then, create 2 additional fields, name Aussie dollar, which is 1.4 times the retail price, and euro, which is 0.82 times the retail price. Be sure to round all your expression fields to 2 decimal points. When you're done, your screen should resemble the figure you see here. Skill Check 2. Find the 773 records in your customer table where the customer type is consumer. Show the customer ID, customer type field, and a full name expression field. Your results should be sorted by the full name fields Z to A. When you're done, your results should resemble the figure you see here. Skill Check 3. Join the sales invoice table to the current products table. Show the product ID, product name, and retail price from the current products table. Show quantity from the sales invoice detail table. Create an expression field called Subtotal, which multiplies the retail price by the quantity. When you're done, your screen should resemble the figure you see here. Skill Check 4. Modify your query from Skill Check 3 using the round function. Show retail price and the subtotal expression field rounded to the nearest penny. When you're done, your results should resemble the figure you see here. That does it for Lab 3.2 on expression fields. Next item, let's do Lab 3.3, identity fields.